In all kinds of internet services, users access the product or items in a chronological order. This property facilitates a non-trivial recommendation task called sequential recommendation. For example, suppose you are a guy just moved to a new apartment. The first thing you might want to do is to buy a new bed frame. After that, you might want to buy a new mattress and put it on your new bed frame. Then, maybe you want to buy a new pillow and blanket. However, sequential recommender systems still face several challenging problems. The first one is how to model the long-term user interests from sparse implicit feedback. The second one is how to capture the short-term user interests given several items the user accessed. To cope with these challenges, we propose a hierarchical gating network, including the embedding layer for hidden representations of users and items, the gating layer for adaptively selecting informative items and features, and the prediction layer for learning pairwise user preferences. To be more specific, at the embedding layer, we get the corresponding item and user's embeddings, which are low-dimensional, real-valued, dense vectors. Then, at the gating layer, we use the feature gating to capture item features that tailor to users' preferences, and we select the informative items that are helpful to predict future items with the instance gating. We then aggregate separate item embeddings into one group-level latent representation. At the prediction layer, we use group-level latent representation we obtain from the gating layer to model the user's short-term interests. Then, we use item-item product to reflect the relations between item pairs. Finally, we model user long-term interests with the classical matrix factorization. At the end, based on these three terms, we get prediction scores of users on items. The experimental results demonstrate the effectiveness of our model on top-end sequential recommendation. Please check out our paper and source code at this link. Thank you.